Good evening, and welcome to our podcast on the Gini coefficient calculations for the three major sports teams with Alex Stevenson and me, Rugi Kamara. I'm not going to give you short intros on the Gini coefficient and Lorenz curve. Now, the Lorenz curve is a plot of percentages that shows a percent of population on the x-axis and the amount of capital, that percent, or the spend, i.e. income, on the y-axis. The Gini coefficient is the difference of the area between the Lorenz curve and the line of a perfect equilibrium. We did find that most recently the coefficient in the United States was 41.4 as of 2018. Tonight's hot topic, we're going to talk about the Gini coefficient of the three major American sports teams and what they mean.
One of the questions we'd like to answer from these Gini coefficients is how does baseball's lack of a salary cap and salary floor influence its Gini coefficient? The reason for baseball not having a salary cap or salary floor is because the owners nor the players' union has offered one. This is most likely because the players want to just keep getting money, so there's no salary cap, so the big teams can keep spending a lot of money on them, where the owners, if they implement a salary cap, will probably have a salary floor, and they will not want that. Is there a difference between the NBA and NFL Gini coefficients, and do they make sense? The dead caps effects on the NFL, so bad teams probably have more dead cap. Does that increase or decrease our Gini coefficients? And how does the 2016 salary cap burst influence the NBA, where every team got about $24 million in salary cap that season? For data collection, data was collected via SportRack and was taken from the years 2010 to 2021 for the three major sport leagues.
And as well, in this example, the data was collected for the MLB season of 2021. We took this team number and the 2021 total payroll and put these into our Excel sheet.
Summarizing our data, we tend to see the trend that the MLB and NBA spent the least money, where the NFL spent the most money.
Over the years, the leagues have shown an increase of money being spent as data collected. MLB was the only league to a team over $300 million, having absolutely no salary cap. This is ridiculous. I can't believe it. I hope you got some type of solution here.
I know. It's crazy the amount of money that MLB teams can spend without their salary cap. The percent of the league is measured as PJ in our model, and the percent spent will be measured by LPJ, and these will create our Lorenzo curves. Here we can see some example of our Lorenz curves. You can see the first one is the NBA. You can see that it somewhat closely resembles that line of perfect equilibrium. You can see then the next one, MLB 2011, and you can see some variation. You can see a little bit of a dip in the middle, a little more than the NBA, and a lot more than our last one in the NFL, where you can see that it's pretty close to the line of perfect equilibrium. You can't really tell even much of a difference between the two of them. Here's our method of numeric integration, which we used to get our Gini coefficients. We did this by taking the integral of 1 to 0 of L of P, which is an equation we got from Excel graphs and our line of perfect equality. The reason we set our integral up like this is because it has an area similar to a triangle when you look at it between the line of perfect equality and the Lorenz curve. It sets up an area that's similar to that of a triangle.
Now we have three different rules we're learning here: the midpoint, trapezoid, and Simpson's rule. Now in the midpoint rule, the height is derived from when x is 2 subtract 2i subtract 1, as well the evens would then represent the length. This gives the area of the rectangle. Now in the trapezoid, the half is derived from the area of the trapezoid. When x of 2i subtract x of 2i minus 2, this shows now the length of the base, indicating the change of x. So when f of x of 2i plus f of x of 2i minus 2, this now shows the height of the trapezoid for each x as well. The half will also indicate the average height between the x's of the base. Now the Simpsons rule. We all got to wrap it up somewhere. Now, in this rule, we have both the sums of the midpoint rule and trapezoid having the same limits. So we can now combine it under one sum. So we do this by factoring out x of 2i minus x of 2i2. Then we create a simpler equation. With this simpler equation, we was able to utilize it and put it into our Excel to collect our data. Here shown here in this example here. Now, as you can see in this table, we compare our Gini coefficient values with our averages. Now we can see the MLB has the largest Gini coefficients, followed by the NBA, then the NFL.
So here's the part we've all been waiting for, the analysis of our Gini coefficients. We can clearly see that the Major League Baseball lack of a salary cap or salary floor influences its Gini coefficients, as its coefficients are a lot larger than that of the NBA and NFL. The NBA and NFL Gini coefficients are extremely close to being equal. They're both pretty low, and the NBA is slightly higher. We can think of this as maybe teams in the NBA, quote-unquote, tanking, which was a major problem during the mid-2010s, where if teams don't have good players, they kind of eased off the gas, stopped spending money, and tried to lose in order to get better draft picks. We can also see that from these data points, the 2015-2016 season, 16-17, and 17-18 in the NBA, there was the increase of salary cap in 2016 didn't bring a increase in Gini coefficient. This is because the amount of money being spent doesn't really affect Gini coefficient. If all teams are spending money, then there's no real effect to Gini coefficient. And since the salary cap went up for every team, then there was really no effect for the Gini coefficient at all. And so then we can look at something that we kind of thought of here, which is how did COVID affect these leagues? And we can see that really the NBA and NFL are extremely close to their averages in Gini coefficients, and next year's they were extremely close as well. But you can see in Major League Baseball, in the 2020 season, the first season affected by COVID, you can see it's about on average, just a little bit above. And then the next season, though, it skyrockets. So we can maybe interpret that as the major teams in Major League Baseball, the ones that always spend money, were able to still spend money because they still had big-time TV deals and big-time games. Where the smaller market teams, not having fans in the stands, were probably more greatly affected, so they would spend less money. So you could see maybe a little bit of effect of COVID-19. That could have also been an outlier, though, for the 2021 season. But it'd be interesting to see maybe in the 2022 season if this trend continues or if things kind of come back down to that more 0.2-ish range where the MLB normally was.
This concludes our little short mini podcast here with me, Ruby Kamar, and Stevie, or as you know, Alex Stevenson. You guys have a good day. Hopefully, give you guys a great informative information about the Gini coefficient and no salary cap on the sports team in America. And I still cannot believe these goddamn MLB players do not have a salary cap, Stevie. Dang it. I see why you want to be a baseball player.